All right. So the 10.5, the further applications for the ideal gas equation. Essentially what we're doing here is just using PivNert and like adjusting some of the parts of it or whatever for like depending on what they give us in the equation. If they give us like different information, we can still use this equation and solve for certain things. So density, if you hopefully remember the equation, if not, it's right here. Density is mass divided by volume. Okay, this is just in case. Lowercase m. And then, so density is mass divided by volume, right? We've got PivNert that we have already looked at. If you were rearrange PivNert to have N over V, okay, N is number of moles, V is volume, right? So if you take the number of moles times the molar mass, so let me get another sheet of paper here that I don't want to write it on here, but just to kind of give you an idea. So like if you had 5 moles of water and you wanted to turn that into grams, you would do 1 mole of water, 18 grams of water like this, right? And then whatever that comes out to be. 90 grams of water. Right? Yes? Okay. So if you look at this really basically, what do you do to turn moles into grams? You take the moles times the molar mass, that gets you to grams. So if you look here on our notes, what are we doing? Number of moles times the molar mass will get you the grams, the mass in grams. That's all this is, okay? Density is mass over volume. So what they've done with this, with PivNert here, is they've rearranged it with number of moles over volume, but that's not density still. You'd have to get this to be mass. So you have to multiply the N by molar mass, which they did here, but you can't just add molar mass randomly. So they multiplied molar mass on both sides. Like in algebra, if you do one thing to one side, you got to do the same thing to the other to keep it equal, right? So they multiplied both sides by molar mass. This becomes the mass over volume, which is density, like they have down here. P, and then it's pressure times molar mass over R times T. Make sure you differentiate between lowercase m, which is mass, and uppercase m, which is molar mass. So this is rearranged into this equation. Density equals pressure times molar mass over R times T. Everybody okay on that idea? Okay, and then all they did here is rearrange the equation to solve for molar mass. Rearrange this equation to solve for molar mass. All right, any questions on like rearranging it or how density can fit in? All right.